So welcome everyone to this seminar. My name is Andrew Smith. I'm the director of the Center for Smart Streetscapes and a professor in the Department of Civil Engineering and Engineering Mechanics here at Columbia. So this lecture series, I think had previously called it, I think it might have changed its name, but it was the CS3 or Center for Smart Streetscapes alumni lecture series where past students from the research center were sharing their research, their experiences as they transitioned into industry or other careers with a group of current day students. And I'm extremely delighted and also very proud to introduce today's speaker, Patrick Alrassy, who is really, I would say, an alumni from before our center was established. He graduated with his PhD 2 years before our center was awarded and began, and some of his work, I think, was instrumental in us winning the center from when he worked together with me, as we were able to use that and the fact that it was being used in the real world and validated as a credible example of the kind of work that we could do to make an impact in our cities. And so Patrick went on to, his first job was at Optimus Ride, and then not after a few years, transitioned, I guess he will share this story with you, but transitioned over to, was it still called Facebook?
Meta.
That was already Meta then. Okay, so Patrick will tell the story. So again, really delighted and very proud to welcome Patrick Alrassy. The floor is yours.
Thank you, Professor. Hi, everyone. I'm really happy and grateful to be here, and I'll promise to be as beneficial as possible. And I'd like to thank Fernanda and Professor Smith for inviting me. Let's start. But before that, feel free to interrupt whenever you want for questions. I mean, I think I will not be able to see everyone, so everyone's hands maybe. So just feel free to jump in and cut me. I would love that energy. All right, so I'm Patrick Alrassy. So as Professor Smith mentioned, I was doing my PhD at Columbia University. I started in 2017. Before that, I did my bachelor in Lebanon in civil engineering, and my master's in the University of Texas at Austin in structural engineering. And the way I was introduced to my PhD program and to Professor Smith was I had an internship during my master's in Manhattan, and I was doing like structural design, and I didn't see myself in that doing that with all my due respect. So I thought, why not going into PhD and start teaching in structural engineering? So that was my goal. So I emailed Professor Smith, and he interviewed me, and that's how I got into Columbia to do structural engineering, particularly structural harmonics. And then, actually, Professor Smith and back then Professor Jinwoo Zhang, Professor Jinwoo Zhang was PhD student of Professor Smith, and then postdoc. They won a project with New York City Department of Transportation, and it was a big data project, like where they had a massive amount of telematics data with OBD onboard diagnostics data from 27,000 vehicles that belong to the city of New York, and as part of the New York City Vision Zero project. And with that data, what we wanted to do is to, understand the road network behavior of the city and build an impact in order to improve the safety of New York City streets. And luckily, I was placed in that project. And since day one, I told Professor Smith back then, I still remember, I told him, I want to focus on, like those buzzwords, ML, where they were requiring ML, AI, big data engineering, infrastructure, and so on. I told Professor Smith, I want to focus on that. And this is how I made the shift into where I am today. That was my starting point. After just in a summary, after graduating, I went to a startup where I was acting as a data engineer / research scientist to measure the safety of the software of the autonomous vehicles. And then after that, the startup was acquired with $0 returned to me. And then I interviewed for 4 months up until I got Meta, and we're going to talk about this. I spent 2 years at Meta's Oculus department, part of the spatial AI, trying to measure the safety of mixed reality and the 3D digital mapping technologies, as well as localization technologies. Also, we're going to talk about them, dual positioning systems. And about 3 years ago, I decided to switch into what was so-called Gen AI department to work on Llama models, and which now was transferred to be called Meta Superintelligence Lab. And I'm now part of that team, working particularly on AI evaluation. I will spend 2-3 minutes, maybe a little bit more, on what was my research. The first research project that I've worked on related to like techie. Yeah, as I said, we got this data and we wanted to build a driver behavior safety index, and from that build an injury prediction model, and then develop some tools for New York City Department of Transportation to be able to, for example, say, find me the speed at 3 p.m. on Fridays on 5th Ave and I don't know, 42nd Street. We want to do an intervention there. What is the congestion there? Where is how harsh is the behavior of drivers, and so on and so forth. So we developed for them this web tool to be able to run such queries. And then also this driver behavior and the algorithms that we build for the systems were also used by FDNY for their ambulance routing optimization. So basically, this data was comprised of GPS noisy data points that were that were sampled at 30 seconds intervals, and every data point had the driver speed directly sampled from the OBD sensors of the vehicle, as well as when the driver hit a hard brake or hard acceleration, and so on, above a certain G threshold. And our first job was to actually denoise this data and build what we call map matching, an map matching algorithm that try to predict where the driver actually drove. And we couldn't use those off-the-shelf tools because NYCDOT and city departments use their own digital map. Some of the, like Google Map, for example, only worked on Google digital map. Back then, this open source BMW Barefoot only worked on OSM data, and so on. And the way we approach the problem, again, that was with Professor Smith and Professor Jinwoo, is to treat it as a hidden Markov model problem, because your observed points are observations, and you're trying to predict those hidden states, which are your road segments you drove on. So I spent 3.5 years trying to come up with emission and transition probability. But in a nutshell, yeah, it was super fun. We were lucky we had the speed of the driver in an interval, so we were able to compare it with the shortest path, and assuming that the driver from one GPS point to the other took the shortest path, we can, assign a probability to each transition from one segment to the other. And then the innovation also was that we turned the problem into a Dijkstra problem. The way we turned that is that imagine every GPS point now has many candidate road segments around it, and we want to predict for let's say for a window of points, let's say 20 GPS points, we want to predict what is the most probable path that the driver took. We assign a weight or a cost for each path, which is coming up from the driver's speed and the shortest path and and the noisiness of the GPS. And then since now you have the weight or the cost between a segment and the other, you want to try to minimize the cost, or in a sense, or maximize the probability or the most probable path that the driver took. So it's really a Dijkstra problem, and that's how we approach this problem. And another thing is we ensure continuity of the trajectory by setting the last, 5 costs as zeros, last result ones, so that we maintain continuity. We also, back then it was still like we're talking here like 9 years ago. Big data was still, like ramping up and so on. We developed a router in Redis in memory that would, because we discovered, okay, those shortest paths between road segments, these are constants, they don't change, right? So these computations, we don't really need to compute them live. We can pre-compute them and sharding them by borrow logically. Because if you're driving in Queens, you don't really need to have in memory Staten Island road network, right? So we made some like nits and bits in order to make to process 3 years worth of telematics data from thousands of vehicles, and have it finished so we can move to post processing. And also, we made use to we had in mind a way to also try to understand the noisiness of the GPS signal in the city. We made use of the altitude, if you remember, right? So you can see, we saw the altitude, how it gets unreasonable around tall buildings and around subway steel frames and so on. So these are areas where we see the driver is there. We increase the search radius of the potential candidates, so we can have a more accurate map matching. In terms of research impact of this project, basically we had citywide traffic speed distributions and maps that were actually used to install cameras across the city that the DOT used to do enforcement. And again, this web application that they are still using it internally today to query per segment. So it's very granular, as well as the FDNY and DMS departments. We ran them up on the map matching algorithm, and we use this map matching algorithm to map their ambulance trajectories in order to generate some like predictive travel times for their ambulances, in order to save like travel times between the incident location and the hospital. So it was really a fun project, and up until this point, I would say this is the place that I learned most, because you are you have the opportunity to, you're given a question and you want to resolve it, right? And you want to dig to learn, you want to try things, and up until today, I would say this was the last time I had the time to try whatever I want, with no one on my head like, hey, you gotta deliver this next day, or it's like research, and you're free to explore and so on. What I really liked about my research experience at Columbia and with the Smart City Center is its interdisciplinary nature, right? I joined as a civil engineer. I exited as a computer scientist. I entered not knowing how to transform from bits to bytes, and I exited really as a computer scientist. So this is something if you guys have it, it's a real plus to you. And this is where I learned to dig, this is where I learned to self-learn. And it's not like, you're in a class and trying to do a homework, So, yeah, I would think this was the best opportunity I've ever had in my life. And you will see now, as part of my career, you will see like I shift every 2 years to places, like, for example, right after graduation, I went into autonomous vehicles also, although I'm not a robotics engineer. And again, the reason goes back to this interdisciplinary nature of my PhD, where, I took courses in, computer science, operation research, and optimizations, and civil and transportation engineering, etc. So this is a super plus that allows me up until today to jump on any technology I want, right, without having to have a degree directly in that technology. So in the startup that I worked for 2 years, I built something called rare event scenario-based simulation. So basically, this startup had autonomous vehicles deployed in 5 sites across the US. One of them was in New York. And you want to deploy, you want to know if your software is safe before deploying, right? For example, can it handle if a pedestrian jumped right in front of it, or if a bike crossed or a dog crossed? How does it perform in a rainy day? Things like that. These scenarios are really expensive to test them on the ground. So that's why you go into simulations. But then if you think about in simulation, the range of parameters, your environment that you can play with, for example, the speed of the pedestrian, the road type, asphalt versus, other type, millions of parameters, and the combinations becomes billions and trillions, right? So you cannot run all for a particular scenario, let's say lane change, the vehicle performing lane change while another obstacle is driving, while another obstacle is driving, for example, with a pedestrian crossing. You cannot try all of these. So what you want to do is you want to do rare event simulation. Rare event meaning if you want to select from your environment space, basically the most important combinations. And I use safety surrogate metrics like time to collision, minimum distance, and so on to try to understand the high risk test cases. After that, the startup got acquired by a company. I did not like their new business model. I felt they weren't doing autonomous vehicles really. They were doing like assisted driving, and so on. So I started applying to big tech jobs. It took me, I would say, oh, by the way, in order to land this startup, in order to land this startup job after Colombia, I would say I started like 5 months before graduating, doing at night lead code. I'm assuming you know guys lead code, right? Every day one exercise, because it was taking a lot of time, right? I'm not again a computer scientist when it comes to undergrad and masters. So yeah, lead code was a big help for me. I failed. I would say I applied back then 60. I submitted 60 applications, and up until one startup took me. Not because my profile was landing a lot coming from Colombia, PhD, working, with big data, with a lot of tools. You land a lot of opportunities, but the interview process is tiring. It's like 5, 6, 7 rounds, technical interviews and coding rounds, and then you know. So yeah, up until I landed this job, and it was also a good one because startup environments you will learn a lot and you have more autonomy and as well as more scope and impact to land. How am I doing with time? Okay. And so then after the startup again, 4 months up until I landed Meta. Meta, I joined first as part of the spatial AI team, which is responsible for the technology behind Oculus. So when you put your virtual device, we want to try similar to autonomous vehicles, which uses SLAM, meaning so simultaneous localization and mapping, right? Oculus also uses SLAM, and the cloud version of SLAM is called VPS, so visual positioning system. Meaning, when you put your device, we want to recognize whether this is a known room where you previously put your holograms on, so we can display your content and you don't have to grow the content again. So I learned the technology on the job because, again, the interview process is similar. Coding, 5 rounds, you learn the job with some previous experience, similar in SLAM, autonomous vehicles, and things like that. I could land the job, and this is where I focus on measuring map quality, the map. For example, when you rebuild the map, how aligned is it with the previously stored map? And the guardian that you draw when you are in virtual reality. Could we find your space, yes or not? And if we found your boundary in virtual reality, is it really safe, or we are telling you it's safe and you have an obstacle? So it's also about safety. So the term surrogate safety metrics started from my PhD, continued with autonomous vehicles, and here we go now here in spatial AI. And funny enough, actually, I got my green card because of the surrogate safety metrics. So yeah, it's funny. I was able to make a case. Now, all right. Now, 2.5 years ago, I started. I was a little bit bored of spatial AI, my experience. So I decided I want to join the Llama team. I joined right at the end of Llama 2, where I focused on building evals for pre-training teams, meaning so like in pre-training, when you pre-train a model, it's basically you're teaching the model to do next token prediction, right? So the model does not know how to do instruction following, so it's really hard to understand the capabilities of the model. You cannot say to the model, solve me this equation and then wrap your answer and at the end with this so I can extract it and score it, right? Doesn't know how to follow instructions. So the problem is really harder. You gotta design your evals in a way that is pre-training friendly. So that's what I focused on. Basically, if you are doing evals correctly and you are sincere with your model training, you want evals that doesn't exist on the internet. You want to avoid for reasons that I display here. I'll share the presentation later, but mainly because you don't want your evals to appear in your training data, because that's memorization and that's not generalization, right? And most of the benchmarks that we know, like MLU, JSDK, and so on, we know that they are gained. I don't want to claim they are gained, but researchers can gain them if they want, right? So you really want to build evals from scratch, and there are a lot of ideas to do that. I cannot share very much, but they say, you can check. They say like a training model is a property of its monorepo, meaning the repo that was the code repo that was used to train the model, or the code behind train the model, can be used to eval the model, whether it can predict the next code word eval. So yeah, that's what I focus on building evals. Can your model be can your model be your lawyer? Can your model be your doctor? Can your model be your financial analyst, and so on? So also on capability buildings. Yeah, and Fernanda mentioned that you guys, I mean, I could share my perspective where we're going with Gen AI, but for sure I'm not the fortune teller, right? But I would say it's really the time of the applications to Gen AI, right? The models have gotten super powerful. They need like a little bit of fine tuning to be able to go into separate applications, right? Like for example, drug discovery in medicine. An area that I'm very interested in is AI for material science. That I think I would be very happy if I go work on it future, which is, for example, designing new batteries, new materials, new crystals, like materials that are stable in like very high temperature in certain condition, that are specific weight, and so on. Because usually this requires a lot of back and forth in R&D and a lot of time. Just simply Gen AI can, with some fine tuning, can be very helpful there. Also, I would think humanoid robots are also going to be part of the future, and of course new proteins, new inventions in biology, and new chips, and even new algorithms to for Gen AI. So we're also getting there. Now, will job vanish? I don't think so. They will actually, I think, morph, right? They will change. So jobs will become like interdisciplinary. You will have we won't beat an LLM in coding, but we will beat an LLM in designing or in directing the code, how it should perform in testing, and reviewing, and so on. And I think embracing AI is one successful thing you guys can do, because it increases your productivity by a lot. And there's a lot of people that says someone who doesn't adopt AI will lose his or her job, for a person who really adopts AI. I think that's it for me. Fernanda, wanna move to Q&A, or you guys have any questions? We can go into discussion.
Yeah, there's a few questions here or on there. So for you,
from your perspective, where do you see AI agents different approaches, and what are some
Directions
in AI agents
in research?
in the portal?
Yeah. I mean, AI agents, I would say, definitely things that are already done are, like your tax filing, or things like, some consulting work, some, those software AI agents, right? Like book me a ticket, or
Like from a
you mean like
any frameworks?
Oh yeah, for sure. I would definitely recommend reinforcement learning. This is definitely a skill that is needed a lot, and it's an area of research that is very important. And you know that one, part of the training models is there's one important thing, which is the data, right? And you can get data, like most of labs get it from from the internet, from vendors, right? So there is not much you can prove, like the data, either you have it or not, right? I mean, of course, you can do synthetic data and so on, but the other part that is really important in the recipe is the reinforcement learning. How good is your model? How teach your model to do the right thing at the right time to answer your prompts or so on. I would definitely recommend reinforcement learning. Another thing is GPU programming. CUDA and so on. Again, we live in an era that is energy hungry and compute hungry, right? You need to optimize your GPU usage to be able to serve. If you have the skill, it's amazing, right? To scale your agents and so on. And definitely the math, the usual math that we all learn, like Bayesian decision making, optimizations, computational theories, so on. These are here to stay, in my opinion. Advanced statistical modeling and so on. No matter how you become dependent on AI, you still need this, right? And of course, some physical modeling.
It's super interesting to hear that you can envision a path for yourself moving into like the AI behind material engineering that feels like the traditional like application of graphical neural networks and all the things that have fallen out of fashion recently. Yeah. And so I'm curious, what your perspective is on identifying that as like your possible option for your path.
Yeah. So first, the reason I'm interested in it, I just feel like it's amazing if you can, like, if you have, for example, I don't know, a shortage in batteries, let's say, or you want clean energy or something. It's something like you can serve the humanity, right? So that's from the first. I'm interested in that, and the second is. It's as if going back to the basics, right? Like those physics courses we learned about, those chemistry courses we learned about, the biology and so on. It's like, it's kind of not like nostalgic, like using AI in order to do that. Like, okay, now I'm building AI models, and but like. And meta can survive if I go away, it's not like, but like building something really new that would serve the humanity, I feel like I wanna do that, and I wouldn't be scared, like I don't have a PhD in physics, but I have this degree, this program that you guys are in, or this path, this undergrad, master's, PhD. Believe me, it will teach you really to self-learn. You can be wherever you want, and these days it's very easy to ramp up and catch up in any field you want, right? So, and again, it ties back to this interdisciplinary era, and you no longer are like narrowly or experts or people like experts narrow rather like cross domain. Did I answer that?
Yeah, I think so. I'm definitely a little curious to hear whether being able to adapt AI for these purposes. I do think that will involve like embracing the everything's a sequence modeling problem that like really has turbocharged today's AI, or if it'll involve going back to like the more purpose-built AI architectures, like graphical models, things like that.
Yeah.
So, on Zoom are having a hard time hearing the question.
Oh, I see. Okay. Yeah. So I think both, to be honest. I think definitely we'll do AI, like new AI architectures, and even going back to the fundamentals and so on. Like for example, for designing new crystals, right? You still need those there's this something technology that's similar to finite element methods, like where you reiterate and reiterate in order to test whether your crystal can last in the environment, is stable, and so on, right?
Yeah.
You can leverage the GPUs and so on, but you still rely on that.
Part of the architecture is the generation.
Exactly. Mhm.
Big hazard, thanks for your talk. Did you know if Meta considered or tried to use RL or other optimization types from prior kernel optimization to improve the current time deployment? Feels like for real world large scale applications, current time optimization is important.
Yes. Definitely inference and optimizations are important, specifically. Oh yeah, I need to repeat the question. So the person on Zoom is asking whether Meta. I mean, I cannot speak about Meta for sure, but if kernel optimizations or people or labs are doing kernel optimizations and inference optimizations, yes or no? Definitely, and the reason of that, because again, the energy hungriness that we live in, right? So so kernel optimizations is one technique that like save you iterations when you forward the network, right? And another technique also is again the breakthrough of mixtures of experts, right? The MOEs, which is let's say we have a model that is 600 billion parameters, right? And we don't want to decrease the number of parameters to not lose accuracy on downstream tasks, but we wanna iterate over a set of parameters at each token, right? When we do the fast forward. So at every time we load part of those, we make those part of those parameters active, so that we save some computations. So that's also another technique.
Nice question. So just want to tie together a few things that you said. You said now is the time for AI-based applications. And you've also worked with like autonomous vehicle company. Curious, AI obviously sometimes outputs things that are erroneous, right? And I'm just wondering if you had comments on AI as used in autonomous systems, but that are safety critical, and maybe also have to run really efficiently in real time. These might be smaller models. Like, is that the place where we need to introduce a lot more physics-based constraints? I'm just wondering what your thoughts are on maybe you faced these questions already.
Yeah. Yeah, definitely. I mean, I read a lot on this matter. For example, and before for example, we used to rely a lot on computer vision to detect stuff, right? Right now, Gen AI can you train the model and it's able to detect such things. But I think what people are doing is fine tuning the model, and they're like set of a lot of set of private data in order to do that, and definitely they are going back to the physics. So.
It sounds like in the previous question, you were alluding to mixture of expert models with like only sets of parameters being active, where Meta has a kind of unique approach to doing mixture expert models. Maybe you can't speak too much about Meta's own approaches, but say a little bit about why, but like letting
Uh,
Or I also get it as confidential.
it is confidential, but so I would say that, I mean, it's also intuitive, right, to have a router that actually, that knows the experts for you that are relevant to the token, right? But as Y tool, I'm more into like the AI evaluation part. It's not like part of the core model. But we're gonna release soon, hopefully the Llama 4 paper. That's as far as I know. So,
So, great presentation. I wanted to, so it came out recently in the news that Meta is actually releasing bonds to raise $30 billion of more AI spending because their incredible cash flow is not enough to match the amount of spending that they are putting into AI. So, but there are challenges from all over the world, particularly in China, with DeepSeek and other Chinese companies spending less money, maybe only $500 million in producing an XM model. So I guess I want to hear about your comments on what do you think the future of Meta's business as well as the generative AI group.
so again, I cannot speak to Meta, but as a personal opinion, maybe we should start with it. No, my personal opinion is it's not gonna last that we're gonna be a lot of energy hungry over time. So there gotta be an invention where we need less compute without using less flops, right? How and who arrives to it, I'm not sure. So I don't think I answered the question, but I think we have to. But at the same time, I think it's gonna require change in model. Right now, I would say all labs kind of do the same. The difference comes in the data, or in the data training, the data ingestion, but data gets good, how much you are curating and making your data high quality, because also that's tied to energy, right? Because if your data is crap and it's not well educated, then your training and learning use for nothing, right? So yeah, currently data and reinforcement learning. Later on, I think model architecture. The RL part is the fine tuning.
If we're on the same level, seems that these days the research that's a bit into the academia and into the industry for gap and for because the industry they have they possess the resources the management that's not the full consuming. Do you think this gap is still growing, especially given the development of the large model? And if it is, how you adapt and develop they want to see.
Yeah, actually, very good question. And I used to think that the gap is very high until I noticed that MOE, for example, is invented by the University of California. I think it's Stanford or Alrassy, which is part of Stanford. So I think that for sure the big labs have the money to have the GPUs and so on, but I think there are partnerships with professors, university labs in order to advance the research. I don't think the gap is personal opinion.
Do you mind talking share your screen?
Oh yeah, for sure.
Sorry. Sure.
And my was so about your journey and so many different types of work here. You mentioned that working on a startup was that. But I was curious why first startup and why.
I see. I'll give you the sincere. So again, the startup. When I joined the startup, I said they gave me like I think that was back then like 5K options, and I thought they're gonna become $50 million after like I don't know 10 years or something. But then I was shocked like in one day. Oh, no more startup. Yeah, they acquired plus, you know. So I was like a little bit tired of the startup life. So I said I want to join big tech. That was one part of my decision. And the second part is back then that was like 5 years, 4.5 years. The metaverse in reality was like hyping. So I was curious about that. And at the end of the day, it's all about neural net, you know, like, no matter application you do, no matter what. Again, that's the current architecture. So I said, why not? I want to work on that.
And so I had a question of like given your background from like spatial kind of AI, like they like combine spatial and
Very good question. In terms of data, besides deduplication, I would say data quality, right? So, for example, is your data correct, or you're inputting wrong stuff, right? So you always want to have a kind of heuristics. There's a lot of heuristics in this part of the stack. You want to understand whether the website you're scraping is truthful or not, things like that. Also, getting expert data. I mean, nowadays it's for sure a problem, but it is available, but expensive, right? A lot of companies are just doing, data annotations and that kind of things. Also, compute, but not GPU. So actually, for data curations and data preparations, I mean, we always fight for CPUs, not for like batch compute power, not for GPUs. So also this is another challenge that we have. Trying to think. Yeah. Making also there's a lot of like another challenge. For example, there's a lot of Python out there, but there's not a lot of, let's say, Java, right? So the diversity of the domain, like for example, if you're looking to improve your coding, your model's coding domain, you gotta sample in a way. Like random sampling doesn't work, right? You gotta sample in a way that can be good on Python, C++, Go, say that.
I want to make sure we leave time for if anyone on Zoom, or if anyone or parents have any questions or comments or doctors. Feel free to unmute or anyone on Zoom.
I think, can I ask a question, Patrick?
Of course.
Yeah, I think you're kind of one of the very successful example of like transdisciplinary, multidisciplinary, like a researcher student who translated from structural engineering to data scientist, right? And also, if I look at your trajectory, you start with the trajectory data, right? The GPS point, then you move to sounds like video data or LiDAR data, which is autonomous vehicle. Now you are working with LLM, language model, right? So it seems like you kind of jump from like a time series data to the video data. Now you're working on to like a large language model. What are the kind of your advice for students? What kind of thing that bring you connect between these like phase changes? Like for example, like what kind of skill, what kind of aspect they kind of connect you from the telematics to video LiDAR, and what kind of bring you from your video into large language model? Also, you're kind of making good transition every time. I think that's really fantastic.
Very good question. I mean, I know like everyone around here is like has different kind of perspective of what they want to work on, right? For me, my perspective is I want to always work on something hot because that's where, you know, something hot in a sense like something that is very like interesting, you know. So like again, like Gen AI now is a trend. I gotta see how Gen AI fits in my domain. Okay, I know how to do evals. I know how to evaluate things. I've evaluated trajectories. I've evaluated self-driving cars. I've evaluated Oculus. Let me evaluate LLMs, right? So you gotta find a story for yourself, right? That's one thing. The second thing, you wanna always tie your skill set or your, let's say, PhD thesis or your time work is your time. You want to tie it to user value. You want to tie it to safety. You want to tie it to, believe it or not, to dollar value, right? That's my opinion. So, so that's my advice. Always think, okay, what I'm doing must be interesting. It produces this, solves this and that. And that's why I will become, you know, kind of, I don't know, expensive job market. Company X will take, you know. So another thing is to diversify your, while you are here, again, this is, I think, one of the rare time where you can diversify. Learn, take courses, and like, in my, like, for example, I remember in my PhD, I was required to take 10 courses. I think I took only one course in my program. It was like an civil, took only sensing, something like this. I took a lot from operation research, from science, from data science, from, because, you know, diversify so you can don't put all your eggs in one basket, I would say. And of course, like jumping from one industry to the other requires, it's not easy, right? Requires a lot of preparations. So don't feel like, I was shocked at the beginning when I was about to graduate. I thought, oh, I'm coming from Colombia. I went on big data. I parallelized most parallelized. I wrote like 0 to 1 code, and nobody, like, I was shocked how much it's difficult to find a job, but I did not, you know, I failed like again 59 times. I succeeded 1 time. Then also after the startup, I failed 20 and 30 times, because now I have experience. And I succeeded at Meta. I remember I applied to Tesla and failed. I applied to Amazon and failed. I applied to, you know. So my advice is diversify, try a lot of things, you know, spend time studying and prep before you jump into your next step. Did I answer your question, Jinwoo?
Yes, sir. Thank you.
Sure.
I think we're coming around at time. Does anyone have like one burning question that they need to get off their chest? Free, speak your mind now. Yeah. First question.
if I was now a PhD student and I go, I think both, to be honest, are like all big big ideas are coming from academia, right? And because you have the freedom to try, no pressure on performance review at the end of the year, and you have to bring this dollar value to the company. And academia is good, but also industry has its own perks, right? So depending, it's like a balance, and it depends where you are on that path, right? And these days, you know, a lot of my friends at work, you know, they are assistant professors at the university, and they're also part of our lab, right? So this is also possible.
Thank you so much.
Thank you guys for listening. Feel free to connect with me on LinkedIn. If you're interested in Meta, I would advise you to go to the career website and then message me so I can refer you on LinkedIn the specific job profile.
What's happening?
Thank you guys.
Thank you so much.
Thank you.
Good to see you.